Alright, this is a quick lesson on simplifying radicals. So we're going to do some basic things just with plain old square roots that you've probably seen and you know how to do with the factor tree, and then we're going to look into rationalizing the denominator, which you still should have done, but we're going to do a review on it. So first, with the basics, we have number one, square root of 120. So how are you going to tackle this guy? Just break 120 down into its roots, or excuse me, into its different factors. So I can think of it as 12 times 10, and I can break the 12 down into 6 times 2, and I can break the 6 down into 3 times 2. 10 I can break into 5 times 2, and it looks like all these I can't break down any further. I can't break down the 3, the 2's, the 5, or this 2 any further. Your next step is to group these bottom branches, if they're the same, in pairs only. So we have a pair of 2's. If you see a pair, it's just that number. If there is no pair, there's no match for the 3, so we box it. No match for the 5, so we box it. And no match for the 2, so we box it. If they're boxed, they go underneath the radical. And it's multiplication underneath there, so 5 times 3 times 2. So the 3 came from there, that box, the 5 from there, the 2 right there. And these 2's that were circled, they're out in front. Simplifying this on the inside, we have 2, 3 times 5 times 2, 15 times 2 is 30. So underneath the radical is 30. So we have 2 square roots of 30. It's the same thing as the square root of 120. Let's try another one. Square root of 56. Break that down into its factors. 7 and 8 works. 7 times 8 is 56. Can't break down 7 any further, so I'm going to circle it. 8 I can break down into 4 and 2. 4 I can break down into 2 and 2. 2 and 2, that's a pair, so I'll circle it. Put it out in front. This 2 doesn't have a match, so I'm going to box it just like I boxed my 7. If it's boxed and it doesn't have a pair, multiply it underneath the radical. So 2 times the square root of 7 times 2. Simplifying that, you get the square root of 14. So 2 square roots of 14 is the same thing as the square root of 56. Alright, let's try another one with a number multiplier in front. Leave that there, just focus on this square root of 12. So what multiplies to 12? We can have 6 and 2. The 2, that's done. The 6, we can multiply that by 3 and 2. Now these are all done. Can't break those down any further. Look for our matches. We have a match of 2, a pair of 2, so that goes out in front. And then we have 3 all by itself here. That means we put that underneath the radical. Oops, not done yet, not done yet. Let me erase, let me erase. So we just figured out this square root of 12 part, which was 2 square roots of 3. The 2 came from our pair, 3, it was all by itself, so we put it underneath the radical. That's that square root of 12. We still have this times 5 that we left alone, so we bring that back now. Now we take 5 times 2 is 10, and that square root of 3 is still there. So this answer is 10 square roots of 3. Alright, those were the basics, and we're going to use those basics to help rationalize the denominator. So rationalizing the denominator. We have a fraction in here for number 4, and what we can do when we're square rooting is break that up. So we have the radical of the numerator over the radical of the denominator. Okay, so square root of 25 over the square root of 3. Now, what we want to do here is first look, are any of these perfect squares that can make our lives simpler? Well, square root of 25, that's just 5. And the square root of 3, you can't do anything with that. Even if you did your factor tree, you wouldn't be able to do anything with it because it's just going to be the square root of 3 still. But we do not want the square root of 3 in the denominator. It's just not proper form. So we need to rationalize the denominator. How we do this is we multiply by 1 to get that square root of 3 out of the denominator. So I'm going to multiply by square root of 3 over the square root of 3. Anything over itself is 1, so this is multiplying by 1 right here. The reason why I chose square root of 3 is because that's what was in the denominator. What's going to happen is we're going to take 5 times the square root of 3, square root of 3 times the square root of 3 in the denominator, and the neat thing about that is when you take a square root of some number times the square root of that very same number, you're just going to get that number out. The reason why this is true, square root of something is just like saying that number to the 1/2 power. If we have square root times square root, we're saying that number to the 1/2 power times that number to the 1/2 power. When you're multiplying and you have the same base, you add the powers together. So this is 3 to the 1 power, which is just 3. That's what we got out down here. Okay? So right here, the square root of 25 divided by 3 is 5 square roots of 3 over 3. That is our answer. Let's try it again over here. Number 5, square root of 1/2. Take the square root of the numerator, square root of the denominator. So we have square root of 1, that's just 1, over the square root of 2. Get that square root of 2 out of the denominator, so we have to multiply by 1. I'm multiplying by square root of 2 over 2 because that square root of 2 is in my denominator. And when I multiply that through, that's a square root of 2 right there. Square root of 2 times square root of 2, that's just going to be plain old 2, for the same reason that we discussed up there. Now it's okay to have a radical in the numerator, we just don't want it in the denominator. So square root of 2 over 2, that's fine. That's our answer. Okay? Number 6, it only has a radical in the denominator. So 4 over the square root of 2, we just have to rationalize it. So let's multiply by 1. My 1 this time is square root of 2 over square root of 2, just like the last time because there's the square root of 2 in the denominator. So that equals 4 square roots of 2 over just the number underneath the radical, 2. But we're not done yet. We have a 4 out in front and a 2 below. We can simplify that, 4 divided by 2, to be 2, and then square root of 2. We can still simplify these numbers right here. So we'll have to make sure we do that. Let's look at this next one. 7 over the square root of 8. So to get rid of this denominator of square root of 8, I'm going to multiply it by 1. So square root of 8 over 8. That's going to equal 7 square roots of 8 over 8. And are we done? Well, let's make sure we check the square root of 8 cannot be reduced anymore. So let's look at the square root of 8 for a second. I'm going to move my paper up some. So here we have the square root of 8. Breaking it into its factors, we can have 4 and 2, and then the 4 can be broken down into 2 and 2. Notice we have a pair of 2's, and then this 2 is left over. So the square root of 8 is 2 square roots of 2. This pair is that 2 outside. This boxed single 2 goes underneath the radical. So square root of 8 is 2 square roots of 2. Where you see the square root of 8, let's put in 2 square roots of 2 over 8. This 2 can reduce with this 8. So if we divide by 2, we still have 7 square roots of 2, and take it from the 8, just 4. The other way you could think about it, 7 times 2 is 14. 14 over 8 simplified is 7/4. And then the square root of 2 is still there. So that is our answer for 7 over the square root of 8. Alright, 2 more. We have 9 square roots of 5 over square root of 3. First, let's rationalize the denominator. To do that, we're going to multiply by 1 using what's in the denominator. So the square root of 3 is in the denominator, so multiply by square root of 3 over the square root of 3. That's multiplying by 1. That's going to equal 9 times the square root of 5 times the square root of 3 over just plain old 3. Okay? When you see two square roots, two radicals being multiplied together, you can put those numbers underneath one radical being multiplied together. So we're going to take 5 times 3. That 5 and that 3 I put underneath the same radical. It's multiplication that's happening between there. So 9 times the square root of 5 times 3, 15, over 3. The 9 and the 3 can simplify so that we just have 3 square roots of 15. And let's look at the square root of 15. Can we simplify that any further? Well, if we have the square root of 15, we can break it down into 5 and 3, and those are done. So I would just box them and put them underneath the same radical, but that's just going to come back out to 15. So 3 square roots of 15 is our answer for that, number 8. And lastly, let's try this guy. 12 square roots of 3 over the square root of 6. If we want to rationalize the denominator, look at the square root of 6, multiply by 1. So square root of 6 over square root of 6. So we have 12 square root of 3 times square root of 6 all over 6. So 12, what's in the underneath the radical, we can put underneath one radical. So the 3 and the 6 are all underneath one radical, divided by 6. Okay, so we have 12 square root of 18 over 6. Simplify the 12 and the 6. Divide that, that's 2 square roots of 18. Can we do anything with the square root of 18? Square root of 18 can break down into 9 and 2. 9 can be broken down into 3 and 3. That's our pair right there. So we can write the square root of 18 is 3 times what we have left over underneath the radical. 3 times square root of 2. So we see the 18, put square root of 3, put 3 square roots of 2, excuse me. So this is going to go in right there. So we have 2 times 3 square roots of 2. 2 times 3 is 6, so we have 6 square roots of 2. That is our answer for 12 square roots of 3 divided by the square root of 6. Alright, that's all we have for rationalizing the denominator and your basics with simplifying radicals.